take them order of operations.
Okay. All right. You see the first slide?
Yes.
Yep.
Okay.
Signals and emissions.
So we're going to talk about modulation, which is just the term for how you add information to a radio wave. Or for that matter, it could be a light wave. If you modulate, say you had a laser and you modulate the laser, you could send Morse code via the laser, or you could send voice. In fact, you don't hear about it much anymore, but spies used to use kind of that technique and bounce a laser off of a window and be able to pick up the modulation from somebody's voice in the room and listen to what they were saying. So if you want to send a voice signal over the radio waves, you have to have some way to modulate, which means you either change the amplitude or the frequency or the phase of the carrier signal proportional to your voice. So with a technician license, you're mostly going to be doing FM, which is frequency modulation, where your voice changes the frequency of the carrier. There's some cases where it's actually, instead of the frequency, it changes the phase, but that gets a little more complicated and it's not that frequent with what you would be doing. But it's still part of a question on the exam to know that it exists. So essentially, frequency modulation or phase changes the carrier signal, which is your basic frequency you're operating at, proportional to the volume or the amplitude of the audio signal or your voice signal. On the other end, the receiver detects that frequency change and basically extracts the original audio signal from it. This picture is showing what an amplitude modulated wave looks like, where instead of having a constant amplitude for that carrier, the amplitude changes proportional to the voice signal. Below it is the same modulating signal. In this case, we're doing frequency modulation. So you can see that the frequency of the carrier changes. And in the amplitude case, the frequency will be constant, the amplitude will vary. In the frequency one, the amplitude will be constant, but the frequency will vary. So which type of modulation is commonly used for VHF and UHF voice repeaters?
Delta.
Yep. Delta.
Delta. Okay. We can also send digital information as opposed to voice. And one of the ways is called packet radio, where you actually send a packet of information. Think of it as a letter.
Yeah.
Where, you know, the contents of the letter is the data.
Yep.
It'll have a header, like who it's going to and who it's from. And usually it uses a binary frequency modulation, where you represent what we call a mark in a space. It's like a 1 and a 0. At 2200 hertz for a mark, or for the space, excuse me, and 1200 for the mark. So it changes between those two frequencies because it's a binary or digital information. And those actual packets can be quite long. Trying to remember, like if you're familiar with Wi-Fi or Ethernet, those packets are, if I remember, like 1800 bits long. So what type of modulation is commonly used for VHF packet radio transmission?
Alpha.
Okay, we talked about amplitude modulation. That was kind of how everything started. So we modulate the amplitude with the voice signal. It's not used much except for broadcast radio. In amateur radio, we use a kind of a subset. It's still amplitude modulation, but it's called single sideband because we only transmit one sideband of the signal. For a normal AM signal, you have your carrier, and then on either side of it, you will have the modulating voice signal. The upper side would be normal, and the lower side would be like a mirror. Well, you're putting all your energy into the carrier and those two sidebands. If you eliminate the carrier in one of the sidebands, you have more energy in a narrower bandwidth, and you can get greater distances with that signal for the same amount of power.
Signal to noise, is that like static?
Well, there's always noise that comes from outer space and local stuff. But, you know, there's background radiation supposed it's there since the Big Bang. Establishes the noise level down to like minus 160 dB or some number like that, 170, I think. So the wider the frequency range you're looking at, the more noise you pick up. So if you can narrow that frequency range to the same width as the bandwidth of your signal, then you're going to have the highest signal to noise ratio. I think, well, I thought I had a little chart showing that. Maybe it comes up later. So which of the following is a form of amplitude modulation?
Charlie?
Charlie.
Yeah, Charlie. Yep.
Which type of voice mode is often used for long distance weak signal contacts on VHF and UHF bands?
Charlie.
It's not just limited to VHF and UHF, by the way. I think they just throw those in there to confuse you. Like I said, single sideband, you either choose upper sideband or lower sideband. Back in the early days, it was easier because of the technology to generate a lower sideband signal when you were operating below 9 megahertz. and upper sideband above. That's not a law or a rule or regulation. It's just kind of established protocol. So we still follow that pretty much. So anything 10 megahertz and above will be upper sideband, and below 10 megahertz would be lower sideband. So all the low bands are going to be LSB, and the high ones are going to be USB or upper sideband. There's probably more than one, but one exception is one of the digital modes called FT8, FT4, well, more than one. FT4, a bunch of those that are done with the computer are always upper sideband regardless of the frequency. Oh, okay. I need to put this earlier. The very top, we're showing your modulating signal. We call that baseband. And that's your voice. So you can see there's more energy down here at the lower frequency, and it drops off as you go up. That changes somewhat depending on whether it's a male or female. Women tend to have more energy towards the higher end. At least the average woman.
Yeah.
And that's sometimes why I have to have hearing aids on in order to hear some women, because this is too high. If you have a standard amplitude modulation signal, okay, you will have your carrier, and then you'll have whatever that baseband signal shifted up to the high side of the carrier and a mirror image of it on the low side. When we do single sideband, we filter out the carrier and one of the sidebands, and this is showing we either select the upper or the lower.
Okay, I see it
Now, one of the disadvantages of that is there's no reference. There's no carrier signal to tune to. So when you try to tune in a single sideband, as you get close to it, it starts to sound like somebody talking in a rain barrel. And then as you keep going, it's a Donald Duck. And you got to find the right frequency where you can understand them. So which sideband is normally used for 10 meter HF, VHF, and UHF single sideband communications? Now remember, 10 meters is what? 30 megahertz, right?
Bravo.
Yeah, I think Bravo.
Sure.
Did we guess wrong?
30 megahertz. Where's the divider?
10 megahertz?
Okay.
Yeah, 10 megahertz is the divider.
So if 30 is higher than 10, then what?
It has to be upper.
I missed a step.
Yep.
Okay. If you've ever compared FM radio to AM radio, you obviously know that FM has much higher quality sound because it's a much wider bandwidth.
Right.
AM signals are typically limited to 6 kilohertz, and that's both sidebands. So each one of the sidebands is only 3, which is the same thing you used to get on your analog telephone line. It was limited to 3 kilohertz. So when you talk single sideband, that's the same kind of bandwidth you get as if you had an old hardwire phone. In the case of FM, it's anywhere from 10 to 15 kilohertz wide. So it's more than twice as wide as an AM signal. So you get much greater fidelity, but it takes up a lot more bandwidth. So you really don't get the kind of range you can get with single sideband or AM.
Yeah, I just remember riding down the road trying to pick up radio stations and how often you had to change it compared to the other ones. But then you lost your signal going under the bridge if you were on AM.
Yeah.
Your favorite song came on and then whoop, you're out of the range.
And you probably also remember that at night you could pick up stations that were many states away.
Yep.
And then you
So
go
what's-
by FIT and you can't get your radio station at all. Because all you can get is FIT's FM radio station.
So what's the characteristic of single sideband compared to FM?
I'd say Charlie.
Very good. Yeah, single sideband is definitely not easier to tune.
Oh, no.
And because it's AM, they're susceptible to interference, lightning, and stuff like that. That doesn't affect FM. So it's really the only answer. What's the approximate bandwidth of a typical single sideband voice signal?
You just said it a minute ago. It's Bravo.
Bravo.
Bravo. What's the approximate bandwidth of a VHF repeater FM voice signal?
Ooh.
Charlie.
Yep.
Charlie. Okay, a disadvantage of FM compared to single sideband is that only one signal can be received at a time. There's a thing with FM called capture effect. And the way the FM discriminator works, the strongest signal is the only one it will
Pick up.
demodulate. So if you have two signals that are one's a lot stronger than the other one, but they're both the same frequency, you'll only hear the strongest one. In the case of AM or single sideband, you're going to hear both of them, whether you want to or not.
So is that what's happening when I drive by FIT? Is it FIT's radio station and I'm listening to say the Vero Beach FM radio station and I'm happily going along US 1 and then I get close to FIT and all I can hear is FIT's FM radio station? Is that this?
Yeah, if it, because of something blocking the other signal, if it's going to pick up the strongest one.
Because
Yeah,
they're approximate to FIT, so it's closer, a lot closer.
What is FIT?
Florida Institute of Technology.
Oh, okay.
Yeah, not a radio thing.
Okay.
The university has.
No, I knew you were referencing a location, but I didn't know what that is. Downtown Eustis, if you're driving and you're sitting, unfortunately, at the light, you're overridden by the police department, and they had like, I think it's CenturyLink has a building right there on the corner, and you can lose just about everything right there. Phone signals.
Yeah,
everything.
same idea.
Yeah, that's because of what's called capture effect. It's just the way the demodulation for FM works. So which of the following is a disadvantage of FM compared to single sideband?
Bravo.
Bravo.
Of course, it's only a disadvantage if you really want to listen to both of them.
Yeah. Especially when you got the good song on the station that you're losing.
Okay, so There are some other modes that have very wide bandwidths. One of them that is used in amateur radio is called AM, or amplitude modulation, fast scan TV, and it's approximately 6 megahertz, the same as AM. It used to be referred to as NTSC, which stands for the National Television Standards Committee. I don't know if either of you remember back in the really old days when you'd first turn the TV on and you get this test pattern that said NTSC on it.
Yeah.
Yep, I do. And the TV went off after depending on the station. If you're listening to the news, right after the news, you had the national anthem and
Yep.
In fact, when I was growing up, it was only on a few hours a day.
Yep. Oh yeah, seriously, we were outside playing.
What's the approximate bandwidth of AM fast scan TV transmissions?
Bravo.
Bravo. Bravo.
Oh.
What type of transmission is indicated by the term NTSC?
What? Type of
Charlie?
Oh yeah,
Charlie.
You read
Okay.
faster than me.
One of the other modes, and actually it's becoming more popular lately, which is interesting, is CW. A lot of people call it Morse code because we send Morse code, but it's actually continuous wave where you turn the carrier on and off. It has one of the narrowest bandwidths. It's approximately 150 hertz. So with a technician license, you can do CW on the lower bands, the 80, 40, and 15, and also the 10, where you have some limited voice privileges as a technician. And also you can do it on the VHF and UHF and above, although I'm not sure how much CW activity is up there, but it's allowed. The key, I think, is to remember that it's 150 hertz wide. So what is CW?
Coil winding.
Delta.
Delta.
Which of the following types of signal has the narrowest bandwidth?
Charlie.
Charlie.
That just happens to be the narrowest of the four they showed.
Mm-hmm.
Oh.
Because when we talk about some of the digital modes like FT8 and FT4, it's 50 hertz. And TSK 31 is, I think, 31 hertz. So what's the approximate bandwidth required to transmit a CW signal?
Bravo.
Bravo. Mm-hmm.
Okay, when you're sending Morse code, originally it was done with what we call a straight key. If you remember the old telegraph keys and you saw the guy pounding out the stuff, it's just a single contact, okay? And you're either closing the circuit or opening the circuit. And it's up to you to manually control the timing. So for a DIT or a dot, that's 1 unit of time. And a dash or a da is 3 units of time. And you have to allow 1 unit of time between them. And then 3 units of time between letters and 5 units of time between words. So you have to do that manually by...
What does a unit of time consist of? What does a unit of time consist of? My husband used to be
it depends on how fast you're sending.
Oh, okay. Because my husband was a...
You send, the shorter the time has to be. But the ratio is 3 to 1.
Oh, okay.
Now, I'm not exactly sure when they came up with the paddle, which is two sets of contacts, and they're usually side by side instead of vertical.
Yeah.
So one of them will, if it's hooked up to an electronic keyer, which can be a separate box, or a lot of the modern radios, I would say most of them, have a built-in electronic keyer. So when you press on usually the left paddle, it will generate DITs at the proper spacing, as long as you hold it. If you do the right one, it'll generate DAWs continuously with the correct spacing. So in the case of using a paddle, you only have to learn how to go back and forth. How long to hold, like if you wanted to do, say, a B, you would hold the right paddle just long enough for it to generate a DAW, and then you would press the left paddle and hold it long enough to generate 3 DITs.
Oh.
So it's a little easier timing wise than having to control everything. And it makes the code easier to decode on the other end.
Ah.
Because of the consistency.
Yeah.
Right. So what is an electronic keyer?
Charlie?
Yep.
Okay, so we talked about repeaters using FM or PM, although I don't know of any around here that use PM. With FM, you can only receive one signal at a time because of the capture effect. Its single sideband is kind of a subset of amplitude modulation, and we use upper sideband above 10 megahertz and lower sideband below. It has a 3 kilohertz bandwidth, much narrower than the 10 to 15 for FM. That fast scan color TV is AM, sometimes called NTSC at 6 megahertz bandwidth. CW is still amplitude modulation. You're just turning the carrier on and off. It's only approximately 150 kilohertz, 150 hertz, that's a mistake, wide. And you can use an electronic keyer to manually assist in sending code. Gets the spacing right and the length. My record go.